It's time to talk about some lines and angles. First thing we're going to do is just talk about a couple of different types of lines. First one is parallel lines. Those are lines that don't intersect. So we'll list a couple example of parallel lines. One would be like AB and CD. So we would say AB is parallel to CD. That would be one example because they're both going front to back. They will never touch each other. So therefore they are parallel lines. So now why don't you see if you can name a pair really quick. And if you came up with anything like AW and DZ, AW and BX, any two vertical lines would work. Any two lines that go left to right would work. So for example, we could have used WZ and XY. So there's all sorts of different ones you could have picked as long as they go from front to back, left to right, or top to bottom, they would have worked. Okay, those would be parallel lines. Perpendicular makes right angles. So that means it needs to be two different lines that intersect at a corner in this cube. So one example would be BX and XY. Okay, so they have to intersect at one of the corners to be perpendicular. Your turn. And I'm sure anything that you picked, as long as it meets at a corner, is going to be fine. So another example would be DZ is perpendicular to ZY. Also notice that they share a letter because that's where they intersect. Now the one that's a little bit confusing is skew lines. So skew lines are lines that are on different planes. So they're not going to intersect, but they're not parallel. And here's an example. So you pick a line that's on this plane way out to the left. So you have AW. And we could say that that is skew to another line that's on the plane to the right that's not vertical. Okay? So that's an example of skew lines. So YZ. Because look, we're going to imagine that these are on different planes. So this is coming out at you. This is not going to intersect that other line somewhere over here because we're pretending that's three-dimensional. Okay? So you can go ahead and try to name yourself a set of skew lines on your own. But I'm sure if you pick anything that's on two separate planes would work out fine. Example would be something on the top and bottom plane. So AD is on the top. And then you pick another line that's on the bottom. We could also say ZY again. Parallel planes, that's the entire plane that's on, say, like top and bottom, like the ceiling and the floor, or the wall on the left and the wall on the right, or the front and the back. Parallel planes are just two different planes that never intersect. So we know the ceiling and the floor should never intersect unless you have some sort of problem. So we would have plane ABC. Could be parallel to the bottom, which we can call WXY. All right, so that's some parallel, perpendicular, and skew lines and some parallel planes. What we're going to spend a lot of time on this chapter, though, is interior and exterior angles formed by some lines and a transversal. So the first thing you need to be familiar with is what are these? So lines, these look like they're parallel lines, and many times they will be parallel lines, but this does not have to work with parallel lines only. We could have two lines that look like that, and then another transversal that looks like that. Basically, a transversal is a line that intersects two or more different lines, okay? So that's why this one we had an intersection point right here and right here. In this example, we have an intersection point here and here on the same line. So that red line is your transversal. Anything in between the two lines is called your interior, and anything on the outside of those two lines is called your exterior. So we have different types of angles that you will need to be very familiar with, okay? So there's two kinds of interior angles. The first pair of interior angles are alternate interior angles. So notice how in this diagram we have the top left and bottom right angles of the interior. So they are on opposite sides and on opposite line. That's what makes them alternate. But they both have to be inside. Your other example is the orange dots. They are both interior, but they're on the opposite side of the transversal and they are on the opposite line. So you just have to get used to the pattern. The other kind of interior is same side interior. And when we say same side, we mean the same side of the transversal. So as you can see, we have two red dots on the left. So those are same side interior angles. And we have two green dots on the right. Those would be example of also same side interior angles because they are on the same side of the transversal. Okay? We have two different kinds of exterior angles that follow very similar patterns. We have alternate exterior angles, which, again, similar to alternate interior, they're on the same, or they're on opposite sides of the transversal and opposite lines. But now since we have to be in the exterior somewhere, we have one at the top left, then we have another one all the way down on the bottom right, because you have to jump over the transversal and then jump all the way over to the exterior of the other line. And that's what makes those alternate exterior angles. Same thing with same side exterior. In relationship to same side interior, they both have to be exterior angles, but they're on the same side of the transversal. Okay, so these just take a little bit of practice, and you're going to have plenty of that coming up shortly. Now the last one is corresponding angles. Corresponding, you're going to have one that's interior and one that's exterior. And the easiest way to think about this is if you had like two different intersections. We'll just say they're like city blocks. And the red dot is on the top right of the intersection. The other red dot is the top right of the intersection. So therefore they're corresponding angles because they're in the exact same position at a different intersection. Okay, the green dot's at the bottom left of this intersection. The green dot's at the bottom left of this intersection. Therefore, they are corresponding angles. So corresponding angles are in the exact same position, but on different intersections. Okay? So those are different types of angles you're going to be working with. So the first thing I want to ask you to do is pause the video after I do one example of each, and you see if you could name the rest, okay? So alternate interior, I'm going to name one of them. The alternate interior angle is going to be angle 3 and angle 6. Okay, angle 3 is on the top line, left side of the transversal. Angle 6 is on the bottom line, right side of the transversal. So remember, they have to be on opposite lines and opposite sides of the transversal. So that's an example of alternate interior. An example of alternate exterior would be angle 1, which is top left. So we have to jump over to the right side, jump all the way down to the bottom, angle 8. But they must be exterior angles. One example of corresponding would be angle 1, top left of the intersection. And then we'd have to go to angle 5, top left of the intersection. Same side interior. Two angles that are on the same side of the transversal and both inside the two lines. That would be angle 3 and angle 5. And finally, same side exterior. We have to pick the same side of the transversal and exterior angles, so 1 and 7. Okay, so I just named one example of each set for you. So now what I would like you to do is pause the video. There is one more example for each of these except corresponding. Corresponding has 3 more examples. So pause the video and see if you can name the rest of these angle pairs. All right, your other alternate interior should have been 4 and 5. Alternate exterior should have been 2 and 7. Corresponding should be 3 and 7, 2 and 6, and 4 and 8. Same side interior should be 4 and 6. And same side exterior should be 2 and 8. Those would be all of the correct answers. So if you got those, you are good to go. So let's make it a little bit more challenging. What I would like you to do is tell me what kind of angles these are. Now you can reference your notes if you need to, but here's a little trick. They're not just vertical anymore. We have angles all over the place. For example, angle 1 and angle 5 are another example of alternate exterior. And if you're having a little bit of trouble seeing it, ignore this lower portion for right now, because that is not part of the transversal line. Remember, they have to be on a transversal. So since 1 and 5 are on the exterior of the two lines on opposite sides, they're just alternate exterior angles. It's just that the transversal is now horizontal and the other lines are vertical. So that's just a little thing I wanted to show you. But what I would like you to do is try to answer as many of these as you possibly can and tell me what type of angle pairs they are. Reference your notes if you need to, if you don't remember all the names of them. And just pause it and see if you can do it. Angle 1 and angle 15. So we have 1, 15. They're both exterior. They're on opposite sides. So these are alternate exterior angles. Next example is 13 and 15. Lower right of the intersection, lower right of the intersection. Same spot, two different intersections, so therefore they are corresponding. 6 and 7, both on the same side of your transversal, both interior, so these are same side interior angles. 5 and 11, they're on this transversal. One is on the right, one is on the left. They are both interior angles, so these are alternate interior. Your next example says 3 and 14. They are on the same side of this transversal. They are both exterior angles, so they are both same side exterior. Angle 3 and angle 5. Notice they are on the exact same intersection. That does not mean that they have a new special name. We can still use things that we learned in Chapter 1. Those are still called vertical angles, just like they were back in Chapter 1. Angle 1 and 11. This was a trick question. If you said corresponding, you are incorrect, and that's because they're not even connected by a transversal. There is no transversal that is connecting those two intersections. So if they're not even on a transversal, they don't have a name. So these are just neither, or no name, or no relationship. And finally, we have 16 and 15. Same intersection again. They form a straight line. This is still called a linear pair. So I wanted to throw in a couple trick ones there for you, because the things you learn in geometry in earlier chapters do not go away once you get to a new chapter. So 3 and 5 are still vertical. 16 and 15 are still a linear pair. All right? So last question. I just want you to name the transversal. So angle 1 and angle 11, they're alternate exterior angles. What is the transversal? You just have to pick the line that they are both on. So angle 1 is on A and B. Angle 11 is on A and C. So your transversal is line A. Okay, that's what we're doing here. And then you go to the next one, angle 1 and 5. So we have angle 1 and angle 5. They are same side interior, but they are both on line B. And then your last one, 7 and 12, you can just look really quick and you see that they are corresponding angles that are both on line C. Okay, so that's it. Those are some angles and some lines, and the next video is going to start talking about what kind of relationship in measurement do they have when these lines are parallel. Okay, so we're going to be talking about that in the next video. Otherwise, you're done for now. This is Longo and I'm out. See you, bye.